Hello, welcome to Tech Talk with Steve. Years of installation, design, estimation, project management skills in the ICT industry. And that's right out at the end of my cord from my permanent link adapter.
But we did win this great award for Test Pros.
So I've connected my tester here. This is my remote. I've got the plug from the modular plug terminated end of the link. He opened Wilson Technology in 2004. He brings 50 plus years of telecommunications and information technology. Hello, welcome to Tech Talk with Steve, episode 43, cable testing and troubleshooting scenarios unique to the data center. Today, we're going to be talking about just that. We're going to be talking about testing challenges in the data center. We'll lay a little bit of a foundation as far as the environment that we would be looking at testing in and what type of testing do we see going on? Is it just cable certification? Is that enough? What else do we need to consider? And I have a special guest today. Andrew Froehlich is the founder and president of Colorado-based Westgate Networks, which specializes in enterprise network architecture and data center build-outs. He's highly regarded network architect and trusted IT consultant with worldwide contacts. Andrew has over 2 decades of experience and possesses multiple industry certifications in the networking field of expertise. He's also the founder of InfraMomentum, an enterprise IT research and analysis firm. Andrew is also the author of 2 Cisco certification study guides published by Cybex. He's a regular contributor to multiple enterprise IT-related websites and trade journals with insights into the rapidly changing developments in the IT industry. And he's a regular guest here on Tech Talk with Steve. Welcome, Andrew.
Hey, Steve. Thanks for having me back.
Glad to have you. Glad to have you. So, as I mentioned, teeing it up here today, we're going to be talking about data centers. And we kind of want to lay a little bit of a foundation as far as the environment that we're going to be testing in. So I'm going to go ahead and pull up a slide here. Just got a few images that show the different layouts that we might be talking about.
Yep, absolutely. Yeah. So just to set the stage, there are primarily 3 different architectures that you're likely to run into if you walk into any given data center. So the first one, which is on the upper left-hand side, is the centralized cable architecture. And this is probably the oldest architecture model out there. And this is where all the cabling from servers is pulled back to a central location where switches are located. And this was largely done because data center switches back in the days had to be really large in order to have the amount of backhaul throughput required to switch data from east and west and north and south. So in that situation, problems can occur because so much cabling is going into a single location and terminated in just perhaps one row of racks, that you can have piles and piles of cabling either overhead on ladder racks or underneath the cabling if it's a raised flooring data center. Now, moving on to a slightly more modern approach is the end of row data center architecture. And this is where we're kind of starting to disaggregate the switching hardware from a single centralized location and instead are placing end of row switches in each row of the data center. So in any particular row, any kind of servers or IoT devices that are in these racks, the cabling is pulled back to the end of row server. And then from the end of row server, structured cabling, typically fiber, is run back into an aggregation layer for east, west, and north-south traffic flow. So finally, we've got the top of rack, and this is the most modern approach. And you can even see this in even the brand new spine leaf style architectures. Spines are it's basically an aggregation of layer 2 and layer 3 networking services, and leaves can be considered access layer nodes. Now, the difference between a traditional network and a spine leaf architecture is that in this more modern architecture, each leaf or access switch in the node has to be pulled back to every single spine in the network architecture. And that's done for redundancy purposes and for higher throughput levels. So those, Steve, that kind of sets the stage for what we're going to talk about the rest of this conversation.
Gotcha. So as I'm looking at these, a couple things come to mind.
Mhm.
I notice as we go from centralized to end of row, then to top of row, the shift is less copper centric, more fiber centric as each one
Absolutely.
progresses.
Absolutely.
Okay.
More and more fibers being put into these, with the caveat of there are a lot of IoT devices being introduced into the data center now, whether it's wireless access points, security cameras, temperature and humidity sensors. All those things are still copper connected in most cases and require power over Ethernet.
Gotcha. So some of that copper still finding its way back into the design. Yeah. Okay. That makes sense. And of course, we have to test all that. At the bare minimum, you're going to do a copper certification. And
Without a doubt.
I look at this too, and something else I think of is as that data center grows, what considerations might be important when it comes to increased demand on both those multi-gig copper connections and the PoE? What might you have to think about?
So there's several things you really need to think about. The first one is what type of copper cabling is currently in place. Is it Cat 5? Is it Cat 5e, 6, and so on? And can this cabling operate efficiently when transmitting at higher speeds? When you're talking about moving from 1 gigabit to multi-gigabit speeds. Another consideration is whether added noise due to the higher speeds, whether it will create additional interference that could potentially impact this cable or perhaps surrounding cables in a bundle. Then, if you're talking about the addition of more PoE with IoT devices being added into the data center, you need to make sure that you understand the power load that each PoE device requires, and then whether the PoE switch or the midspan is capable of supporting it. And then finally, if the copper is rated to support that amount of wattage.
Gotcha. All right. I'm going to pull this drawing down now and go back on camera. So yeah. So thinking about that, of course, you have to think about testing considerations, obviously, when
Sure.
it comes to all of that, because you've got the physical cable test, and certainly if you've got things expanding or growing in the data center, or you're considering reusing some legacy cables that you've got in there for newer applications that are going to require more bandwidth, higher speeds, more power for the PoE, as you mentioned, you got to be able to test that. A cable certification test can give you some idea of that, but on some legacy cables, if you're considering putting higher power PoE on there, you want to be able to do something that will allow you to determine, can I actually get the power over this cable? And I'm just gonna pull up my tester here on the screen real quick, and I'm going to connect to a PoE link with this. And this is the same certification tester, because I just want to show what I'm talking about here. We have that PoE testing capability built into the certifier. So I'm going to connect to a PoE link, and right away I can see, yeah, I've got 71.3 watts here. So, and that's, right at this is right at my source. So if I go ahead and do a load test, I just hit my PoE load button. I'm actually plugged right into my my PoE injector here that's tied to a multi-gig switch. So it will give us an idea of what the PoE is there. But what we really want to see, and here we can see, we're getting 72 watts, which is fine. But what if I were to run that PoE through a link of cable? Let's see what happens to that, because this is where, it really starts to come in handy, because you've got that legacy cable. You're not sure, is it going to support my my PoE or not? So I can go ahead and I can run my test, plug into that link, and get it into the right jack here. And then I'm going to go back to my initial screen here. And I see, again, same wattage, 71.3 watts. This is our, what we call allocated power. This is just a discovery. This is telling you you've got the power there. It doesn't tell you what you're going to get when it's demanded by a PoE device. So
Right.
if I click on PoE load test, now I'm running over a length of cable here, and that will have an impact because the resistance of that wire is going to play a role in how much power we can actually get to the endpoint, because it's going to get a drop in voltage. And we can see here, instead of seeing the 55 watts we saw initially, we're at 55 volts, we're seeing 51. And we've dropped from 71 watts of allocated power down to 66 watts. So that's what we're talking about when we talk about being able to look at that PoE. And you mentioned noise too. Of course, we would typically want to be able to run a multi-gig test and look at noise. And this noise that you mentioned earlier with the bundles, it's going to impact the performance of your cabling. So being able to do this out of the same tester is also going to be a benefit. And it's going to give you the information not just about the noise, which to explain it, SNR is showing us the noise relative to our signal. And we want a high number, you want a high ratio there, because you obviously want your signal to be stronger than the noise. And this is going to check our PoE at the same time. So the reason you'd want to run this test, you mentioned that noise with the bundles. This is kind of a real world scenario, what that alien crosstalk is doing to my network. What's happening after all the stuff's been turned up? What's going on around it? Any other influencers that are going to impact the cable are going to show up in this test. And this will test this at multiple levels. Right now it's doing it at a 2.5, a 5, and a 10 gig. If you don't have 10 gig, you can turn that off. You don't have to do all the various tests. It just depends on what you're trying to test. And at the end of that, what we're doing is we're putting traffic on the line. We're looking at that noise relative to that traffic, and we're finding out, can we get the signal? Now, this one didn't pass 10 gig. I don't have a good 10 gig connection here. 5 and 2.5 look fine. It also is going to make a connection test at 1 gig and 100 meg, and then it's going to show me that PoE. It's measuring that PoE as well. So, this is the kind of stuff that we might want to do relative to that noise.
Yeah, Stephen, it really is important to point out that there is more and more noise that's being introduced into modern data centers all the time.
Right.
Especially when you're talking about running PoE devices, when you're talking about running copper at multi-gigabit speeds. All of this contributes to noise, in addition to all the other older ones, such as overhead lighting and things like that, that can introduce noise. And when you have these tightly bundled cables within the data center, which is a very common thing, all this noise that within that bundle can interfere with any other cabling. So it can really be a problem if you don't get a handle on it.
Exactly. So, and we've kind of, we've talked about the real world examples of the noise problems that people run into, and especially if you're using that legacy cable.
Right.
So, installing a new run of Cat 6A is going to assure you pretty much you're going to be able to run 10 gig without a problem. But if you're looking at trying to reuse some of your older cables, they're not going to perform quite as well at the higher speeds. And certainly, a Cat 6 or a 5E are not really intended to be used for those higher speeds over any lengths at all, really.
But you'd be surprised about how many people that actually use them. So.
Well, yeah, and so the really interesting thing, and I think we probably have answered this in what we were just discussing, but
Sure.
but would just a physical cable tester, like a certifier or a qualifier, be enough to be sure that your cable is going to handle PoE and multi-gig speeds adequately? So, just something basic that does a physical cable test for certification, or a basic wire map TDR type qualifier. Is that going to tell you what you need?
Well, I mean, it's a good start, right? It's a good place to start. It'll give you some information, but what's really needed is a tool that can monitor real power load on a cable. And what this does is it ensures that power delivered to the other end of the cable, whether it's a midspan or a PoE switch that's providing that power on the other end of the cable, whether that power is sufficient and sustainable over a long period of time. And most testers on the market today only tell you what level of PoE is possible, and it doesn't actually test the load of the power.
Right, and certainly there's certification tests that will pre-qualify the cabling. They measure DC resistance on balance, for instance,
Right.
both in the pair and pair to pair, and that's critical. It's a good test to run, but it's a test you would run typically after installing a new cable, or if you wanted to check a piece of cable, a legacy cable, and see how it performs, you could use it for that as well. And typically it's an additional test that you add on to your regular certification test. In our case, we include it in the regular test as informational, and if you want to see it rated as a pass fail criteria, you just select the correct limit. Doesn't add any time to it. It does it all in the same 6 seconds. But it's, as I mentioned, a pre-qualifier, so it's telling you that the cabling should support the PoE. And as you mentioned, until you can actually put a load on there and demand the load from the switch, you really don't know how much power you're going to be able to get at that endpoint.
Absolutely.
So how does a user or an IT person, net tech in the data center, know how much wattage a PoE device needs, like the cameras or the sensors or lights? How do they figure out how much wattage those devices need?
Well, the first place to look would be obviously manufacturer documentation, but that's often not available, right? You can't find it, or you don't. You're in the data center and don't have internet access to look something up. In addition, it's often not adequate, as some of this documentation, depending on the type of PoE device, gives you a range of power that's required. And problems can occur with when more PoE is required on some devices in certain situations. So, for example, an outdoor surveillance camera or an outdoor access points, these often come with heating elements in them for cold weather operations. So when it gets too cold, a heating element will turn on and heat up the equipment so it doesn't freeze, right? So when the PoE device senses that external temperatures have dropped to a certain threshold, that heating element is then turned on, and then obviously it requires more power to power that heating element from the PoE source. So this is a situation where intermittent faults can occur, because a PoE device may be functional when operating at lower power requirements, but they'll fail when they ask for more power, because either the sending device can't send enough power, or the cabling can't transmit the power, sufficient power to the end.
So it's important to understand when you're planning the deployment of these devices to know what's the maximum draw they might have
The
in
absolute
that
maximum draw.
worst case scenario,
Correct.
and plan for your total power budget
Exactly.
for that switch. Because if the switch is okay as long as all devices are running at minimum power requirements, but then all of a sudden everything is cold and everything's demanding power at the same time, then it becomes a problem.
Right. And I would specifically say, if you're running PoE devices at higher wattages, so say 60 watts and above, and if the length of the cabling is approaching that 100-meter limitation, certainly test these cables sustained over a period of time. Don't just like run it for a second and then, okay, I assume I can get my required 60-watt maximum. You've got to run that, be able to run that test over time and make sure that
Right.
it's sustainable for a long period of time.
Right. Now, one of the things I'm going to kind of bounce around a little bit here. I want to think about the we talked about the top of rack design, where the switches are all at the top of the rack, so they're not at the end of the row. They're not in a different area in the data center. One of the things that I could envision is if somebody needs to switch something up, they could inadvertently connect to a switch in a different rack.
Right.
Does that happen very often?
It happens all the time. I mean, people are in a hurry, right? So they're trying to connect a new server, and they look up and their top of rack switch is full, right? So the
Right.
next obvious thing is look at the next one. Well, there's a free port, right? So they'll just recable it to that one, and that obviously causes a lot of issues from a management standpoint and a visibility standpoint, because You would assume that every server in that rack is connected directly to that top of rack switch. It's often not the case.
Gotcha. So in a case like that, I think you're probably going to want to have handy something that you can take a look at that port, where you're connected. At some point, disconnect that and find out where it runs. What switch does it go to? Now we can there's always the fallback tone and probe. Everybody has used
Tone
the
and probe or just trace the cabling, but in data center environments, that's often
physically
everything's
trace the
tightly
cabling.
bound up and things, so
Yeah.
that's often not possible.
But I'm going to pull up my tester screen again here, and I'm just going to go into our network test functionality here. And in network test, what we could do is you can connect to that link and figure out what switch it goes to. So once we connect, we can just click on the icon of this tester right here. It's going to tell us information about the network we've connected to. But now I can go in here and tell it I want switch detail. I'm going to just set this to LLDP because I know my switch happens to only run LLDP right now. And I'm just going to, let's run this for 5 seconds and see if we can get any information from my switch. And so we've pulled the switch, and we now know the name of the switch we're connected to. We know the detail about the make and model. We know what port we're on and what VLAN we're on. So this would probably be useful in scenarios like we just described, correct?
Absolutely, yeah. Especially if you've got a large enough team where you've got field engineers that are responsible just for racking and stacking, but they don't have access to actually configure the switch. This is a perfect way to do that. So the field tech can plug in, get the necessary port VLAN information, the name of the switch, the IP address of the switch, read that information to their networking administrators, and so they can configure the port as needed.
Gotcha. And the other thing that you'd be able to do in here too, let's say you did have, you've got something mispatched, we'll call it. I don't even know that that's a word, but we're going to call it mispatched. You've patched into something you shouldn't have.
Mm-hmm.
You can go into tools here, and let's say you've got a user somewhere that's having trouble getting to a particular website. They could do a ping, which everybody can do a ping with a laptop, but it's nice to have it in your tool as well. But if you did a ping to a website and you determined that you weren't reaching, or you were reaching, but it was really slow, then you can come back here and do a trace route. And when you run the trace route, it's going to show you all those IP addresses you're going to go through between where you've connected and where that URL is. And that can give the user an idea, okay, maybe I've got more patching problems than I'm aware of, and I'm running through routers that I shouldn't be. Does that kind of thing happen?
Yeah, absolutely. And so it's nice, with the trace route, you can see the delay at each hop. So if there is a slowdown, you can see where that slowdown is, and then perhaps try and figure out why you're taking that path, and is there a better path, or maybe something needs to be fixed on the network in order to
Right.
fix that.
Yeah, maybe they've got too much traffic running through a given switch or router.
Could be a traffic bottleneck. Absolutely.
Yeah, absolutely. So, but those are some of the things that, and of course a TCP connect, just to make sure you can get your services that rely on a specific TCP port is built in there as well. And in this case, I've got an auto test button here. I can run all these things and save them in an auto test. So you've documented it, which I think is another important part, not just with these network tests. And I'm going to go back on camera here, not just with the network tests, but the PoE and multi-gig and your cable certification tests. We always hammer into people, when you're testing, you want to document everything.
Right.
And for data centers, it's even more critical, in my opinion, that everything is documented. You've got your pathways, you've got your design, you've got everything documented there. You want to have all your test results documented so you know what that cable looked like when it was installed. And then the other tests that we talked about, doing some multi-gig tests to make sure that you've got adequate bandwidth, you don't have excessive noise, those kind of things. And so I would think that having all of that at your fingertips, along with your basic data center design information from a documentation standpoint, would go a long way toward troubleshooting.
Yeah, absolutely. And I'm looking up here. Chuck asked a question, and do you find data centers require documented certifications more than enterprise customers? Absolutely. Yeah. So without a doubt, if you're working with a data center that doesn't require documented certifications, there's something wrong, right? Now the case may not be true the same, at the access layer in a typical office building, something like that. Sometimes they ask for certifications, sometimes they don't. But without a doubt, data centers are going to ask for documented certifications of every single cable that's installed.
Good question, Chuck. And that came in. I didn't even see it pop in. So we must have been on the same wavelength there. Chuck's another regular here. It's good to see him on here. Don't forget to check out Chuck's show Thursday nights at 6 too. Just want to check. I think I had a couple other questions here. We talked about SNR testing.
Mhm.
We talked a little bit about you want a higher number because you're with a higher SNR number. That means your signal is stronger than the noise.
Right.
Wouldn't a BERT test give you the same troubleshooting capability as an SNR test? And are there any benefits one over the other, especially in an environment like this where you're trying to do things pretty rapidly in a troubleshooting process?
Right. Yeah. I mean, BERT tests are great, right? I remember running them decades ago on with AT&T on DSL and lines and things like that. Um, they're fantastic. The problem is that a true BERT test, especially when testing at multi-gigabit throughput rates, it could take hours to receive any type of meaningful information from that. So in data centers where you have hundreds and thousands of cables, you really can't run a BERT on every single one of these cables. It's simply too impractical.
Yeah, that time certainly adds up when you start thinking about how long it takes you just to get the meaningful data for one cable, and then if you've got to troubleshoot more, it just compounded. Um,
Exactly.
so one question here that came in: can the temperature in the data center and or the temperature of the copper cables have an impact on the network performance and the PoE?
It certainly can, if we're talking about extreme temperatures, right?
Mhm.
So fluctuations in temperature, either hot or cold, can certainly impact the performance of a twisted pair cable. Um, the biggest impact deals with what's known as attenuation. This is the ratio between the power input into the cable on one side and the power level that comes out the other end. So that measurement between what's put in and what comes out the other end. So in a perfect world, attenuation should be balanced, completely balanced. The same power that goes into the cable comes out of the cable. But what happens when cables are heated past a certain threshold, they'll cause attenuation to be lower at the remote end, so less power coming out. And the opposite is true for cables that are extremely cold, so that attenuation could be potentially higher for those conditions.
Gotcha. So with a higher attenuation, you lose more signal, and and or in the case of power, you're looking at the resistance too, which is impacted by
Exactly.
temperature too. So,
Yep.
and
Yep.
the higher the resistance goes, the more voltage drop you get, and
Exactly.
you
And
see
and
less
remember, when
power.
we're talking about twisted pair, it's all electrical signals, right? So heat and cold certainly disrupts every aspect of it.
Yeah, yeah. And somebody asked, single test along with PoE. Is it possible through this tester? Yeah. So this tester, there is a standalone PoE test that you can do. It's used for troubleshooting, and then there is a test where you would test the SNR and the PoE together. That test can be saved. The standalone PoE test is not saved. At least we don't have that at this stage. But stay tuned. Our engineers are adding stuff all the time, and when they see questions like this, they start experimenting in our innovation labs. And those guys love to play with new stuff and develop new functions for our testers. So definitely stay tuned. You'll probably see some new things coming from our guy. Um, let's see, does the AEM test equipment allow the user to bundle customizable test methods, e.g. category, class certification plus POE. Oh, good question. So by this, what it does allow you to do, you bundle them in your cable management software, our Test Data Pro cable management, or your test results management software. So you would run these as separate tests. You'd run your certification test. You'd run your, you could run your multi-gig and PoE test, to show your SNR, show your PoE at the endpoint. You could run a network discovery test to show all the devices on the network, show the switch detail for that we pulled up a little while ago. You could run those. Those are 3 separate tests you could run over that same link of cable. So you're going to test the cable physically for certification. You're going to run that multi-gig and PoE test while it's connected to the network to make sure you're getting what you're supposed to at the endpoint. And then you'll run that connection test, the network discovery test, all of which can be saved on that same tester. And then you upload them to the cable management or the test results management software, Test Data Pro. And then you can provide a concise report with all of that in one test report. So you've got that for every single link. You could do that. Let's see. We have a switch. Let's see. We've had a switch out a bunch of the Cat 6 patch cords, small patch cords on PoE install. What do you think on how to test such a small patch cord for PoE, a 6-inch patch cord? So you can do patch cord tests. There are patch cord tests, but they don't test for the PoE. What I would recommend to determine if these patch cords are indeed going to support that PoE, if you've got these 6-inch cords, you're going to run that PoE test that I pulled up originally, just that troubleshooting test. And you're going to look at the load when you've got that patch cord in that channel that you're testing back to the switch. And then if it's showing issues, if you have a problem with it, swap out that patch cord, run another test, and you'll know it's bad. Now, I know that's not an ultimate solution. You want to be able to test these 6-inch patch cords, but there's not really a PoE test for a 6-inch patch cord. And a 6-inch patch cord for PoE, unless there's something really, really wrong with it, it shouldn't make that much difference. But patch cords are key, especially if your overall run is a short run. So, and I won't use the 6-inch as an example, but if that 6-inch does have issues like resistance unbalance, if there's a problem there, then you'll see that show up in a physical cable test. You could run a cable test with that patch cord and without it and see if it contributes to the resistance unbalance. A good example is if you've got, say, a short 30-foot run for PoE, and typically on 30 feet, you're not going to lose much power. So it's probably not going to be too big of an issue. But let's say you've got, 10 feet of patch cords, or, 10 feet at one end and 7 feet at the other end of patch cords. Now the patch cords are a much bigger portion of the overall run of cable. So if those patch cords have resistance problems, they're going to have a much bigger impact on your PoE delivery at the endpoint. And if that resistance unbalance is really out of whack, it's going to impact that PoE delivery, because what happens is the power is not delivered evenly across the pairs. And that's when you start to run into issues with your equipment starting to, it can heat up, it can malfunction, all kinds of things can go wrong when you don't have the proper resistance. So I hope that helps with your question. And if it doesn't, please, reach out to us. You can ping us directly on that. And I think we ran over a little bit, so we're about at the end here. Any last thoughts, Andrew, on the testing in the data center?
No, it's an interesting time to be in the field of IT, especially if you're working in data centers or private clouds or colos or all those types of environments. The requirements are constantly changing, the cabling's constantly changing, so it's interesting to be in this field right now. So,
all right. Well, as always, we appreciate you joining us today. Any of you out there that are going to be going to Bixie, don't forget to come by and see us. We're at booth 820. Starting Monday, I think, is when the exhibits open next week. But I'll be speaking at 2 different pre-conference master classes, one on Sunday morning and one all day Monday ahead of the exhibits. So appreciate everybody joining us. Thank you again, Andrew, and have a nice day, everybody.
thank you. Bye-bye.